In this video, I'm going to go over hydrohalogenation in organic chemistry. So here we have two practice problems where we have this alkene reacting with an HX, where X is any halogen like chlorine, bromine, iodine. In this case, the X is chlorine. So we can think of the alkene as a nucleophile because this alkene here is full of negative charges and electrons. We can think of this HCl here as the electrophile. So I'm going to redraw this HCl out into this form right here, where we're going to say that this alkene could also act as a base, and this HCl is going to act as an acid. We now have to look for the carbon that is the most substituted to give us our most stable carbocation intermediate. We see here, if the carbocation is at this carbon, we would have a tertiary carbocation, and if we have the carbocation on this carbon, we would have a secondary carbocation. Since tertiary carbocations are more stable than secondary carbocations, that means that this second carbon here would have to grab this hydrogen and kick out the Cl right there. Then the intermediate step would look something like this. Right here, where this carbon grabbed the hydrogen, whereas this carbon here lost the bond, which now has a positive charge, and this Cl here left as a Cl minus, which is going to be the nucleophile, where this nucleophile here is going to attack this electrophilic positive charge carbocation there. And that would give us this product here. So here is our final product for the problem, where the chlorine is attached to the more substituted carbon, and the hydrogen here is attached to the less substituted carbon. Okay, so for this, the next organic chemistry hydrohalogenation problem, we have another alkene with another HX, where X in this case is bromine. So then the very first thing to do is to draw out this HBr into this form, and this HBr will act as an acid, and this alkene here, full of electrons and negative charges, will be the base. So we see here, this secondary carbon will hold the positive charge better than this primary carbon. So that means that this primary carbon here would have to grab the hydrogen from the HBr and kick out the Br right there. Then our intermediate would look something like this. So here's the intermediate of this step here, where this primary carbon here grabbed the hydrogen, and this secondary carbon here lost the bond, so it has a positive charge now. But we don't use the Br minus to attack this electrophilic carbon right away, because whenever we have a carbocation intermediate, we always look out for any rearrangement steps. So if we shift it to the right, that would become a primary carbocation, which is less stable. So we don't want to shift it to the right. But if we look to the left and shift the carbocation to the left, we would turn the secondary carbocation into a tertiary carbocation, which is more stable. So the way we do that is that we draw out the invisible implied hydrogen, and we're going to move this hydrogen onto that carbon right there, giving us this intermediate right here. Now, this carbon here gained a hydrogen bond, which is now neutral, whereas this carbon here lost the bond, which is now positive. Now we have a tertiary carbocation intermediate, which is more stable than the secondary carbocation intermediate, and now the Br minus leaving group that left will act as a nucleophile and attack that electrophilic carbocation, giving us this final product here, where our bromine is attached to this tertiary carbon now, and the hydrogens here are left as invisible because it's implied.